Hello all, welcome to this video tutorial series. In this tutorial, we are going to look at how we can create a Gen AI LLM based RAG application on top of a PDF. We are going to create a RAG based application from scratch. The process involves understanding the basic structure of a RAG. We will first look at some theory part of what is RAG and why RAG is so powerful and how different types of embedding and different types of LLM networks we can use inside a RAG application. After then, we will be looking at how using our coding using Python, we can create a RAG from scratch. So let's first explore different parts of a RAG system. There are three parts of a RAG system. The document part, on which we are trying to build the interaction part. Then we have vector store DB, and then we have LLMs and prompts. Now let's try to understand each of these building blocks and how they interact with each other. So inside docs, let's suppose we are building a RAG on top of a PDF. Let's suppose, for the sake of convenience, this document here is a PDF file. Now this PDF file will be converted into small chunks. Obvious reasons, because a big PDF file cannot be directly fed into the system. That's why we create small chunks from this PDF, which we can define in our code on a need basis basically. Then these chunks will be directly converted into vector and they will be saved into a vector DB. There are many vector DB available to our use. For example, we have Chroma DB and we have FAISS. We can use any one of them if you are running it locally. If you are running it on a server, you can use Pinecone as well. But for the sake of convenience in this tutorial, let's suppose we are using FAISS. It's from Facebook. It's much more reliable. In the third part, let's suppose a user is querying something, then we will be using prompts which will be designed by us, and on top of prompts we'll be using LLMs. Now here comes the magical part. Inside this LLM block, we can define any sort of LLM model as per our liking. We can have here openAI, or we can have here like llama. Depending on what we need, we can define our basically LLM model here, and using this we are going to query from our vector DB. Our vector DB will search for the query and it will generate a lot of response. I would say it usually generates 3 or 4 responses. From all of the generated responses, we are going to select the best response, and this response will be fed to the user. Now, this is overall how a RAG system works and how different building blocks of a RAG system interact with each other. Now, let's try to understand in a detail how this documentation part works. This is the first and most important step in building a RAG application. Any sort of documents or PDF or text will be divided into multiple chunks. Not just for the sake of convenience, let's suppose we have this folder in front of us, and this folder has a couple of PDF files inside it. Suppose the name of the PDF file is 1.pdf, and again it has 2.pdf. Pardon my writing skills here. And we have 3.pdf. Similarly, we can have a lot of files. Now, how this code works is like we read each file from this PDF and we will divide it into small chunks. Now, when we say we are going to divide this PDF into small chunks, we are not just talking about all the PDFs, we are talking about the contents of the PDF. For example, if there is a single PDF here, it contains, suppose there are some line written here, then again we have some line written here. What ideally happens, this one PDF will be divided into one chunk, then again one more chunk here. That's how we divide the PDF. But you see the problem here, if we are dividing this PDF into small chunks, there is no relation between this chunk and this chunk. Basically, we are losing the context here. Now, to solve this problem, what we ideally do, let me just clear this and explain it again. Suppose we have this big PDF in front of us and a lot of things written here. Now, to help and contain the context of this PDF while creating chunks out of it, what we will do, suppose there is one chunk created here. The next chunk, when we create it, the way we create it, we take some amount of chunks from this first chunk created already, so that this chunk also has some context from this chunk. That's how we maintain the contextuality. Now let me give you a more live example. Suppose this is a PDF file in front of us. It's basically the summary of my resume with my passion for computer vision and digital experience combined with my expertise, blah 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 and all. So let's suppose there is this PDF content in front of us, and in our code we have decided we want two chunks out of it. So first chunk would be this. So you see at last line, with unique skill set, measuring different emotions in human being. Basically it's a project I did. Now when we create the second chunk, some part of downline are getting embedded here. You see, that's how we create chunks, and that's how we manage to keep the context between the chunks we have created. Let's suppose I have a simple PDF which contains the information, my name is Sunny. So ideally what happens, this PDF will be converted into a lot of chunks. Now since I have only one sentence here, no need of chunks, it will be directly converted into embeddings, and then we will save those embeddings into vector DB. Here embeddings are nothing but the vector form of the sentence. So ideally what happens, each letter inside, not letter, each word inside this sentence will be converted into vector like this, and then these vectors will be saved inside this vector. That's why I'm calling embeddings nothing but a vector form. So ideally what happens, this converted vector not only contains information about this word, but it also contains the contextual information about other words in the sentence. That's why this technique is really powerful. Now let's suppose there is a user and he tries to query what is my name, and moment we type what is my name, this is also getting converted into vector. This vector will then be passed into this LLM, and using LLM we are going to query from this vector store.db. So in an ideal process, what we do, we create embeddings of our PDF and we usually save it into DB, and then there is no need to interact from this PDF at all. We can directly interact from this DB. This saves a lot of time during processing. So this is how an ideal process of a RAG looks like. Now let's try to create this system using our code. Before we directly start or jump into our coding exercise, let me show you all the necessary libraries which we are going to need. So this is the requirement.txt file, and these are all the libraries which you need to install to move forward in this tutorial. You can download this requirement.txt file from the GitHub link shared in the comment itself. So that way it will be super easy. So ideally we set up a new Python environment, and in that environment we are going to install all these library through requirement.txt file. A simple pip command is really helpful here. Now once you install all of these libraries, you are also going to need install Ollama. So it's super easy to install Ollama. You just have to go on this .com ollama.com downloads. You see here, the moment you click here on downloads, you can install whether you want it for Mac OS, Linux or Windows. Since I'm using Mac OS, I will just download Mac OS, and it's super easy. It's you just have to drag and drop the DMZ file. Once you have installed the Ollama, this is how you can interact with Ollama. Basically, it's easy to interact with Ollama in your system. Let me open the terminal for you. There's the terminal, and once I type Ollama, it will show you all the available commands for you. Now I have already pre-installed certain ML libraries, not ML, the LLM libraries. Now let me show you how you can interact with any LLM model locally using Ollama. So you just need to see which model you are going to use. For the sake of convenience, let's suppose I am using Gemma 2. Where is Gemma 2? Oh, there is wrong spelling there. Gemma 2. So for the sake of convenience, I am using Gemma 2 billion parameters model. Let me just copy it and I will paste this here. Ollama run Gemma 2. The moment I run it through, it will just create a manifest, and this is how you can interact with it. Now I can interact with using hi, how are you? So basically here we are trying to interact with Gemma 2B. Similarly, we can interact with Ollama or any other LLM model which you are gonna need. You just have to you see the response here. Okay, I'm doing well. It's pretty easy. Well, installing Ollama and using LLM models through it, it's pretty easy. Just in case if you want to use any other model, suppose for example you want to use Ollama, llama, basically llama 3.3. So you can choose which version you want to use. 70 billion is a very big parameter, so I'm not going to run it, but this is how you can run it. Llama run, and this is where you specify the name of the LLM model. It's super easy. Now since we have set up these two things, now it's time to start our coding. So let's get to our coding exercise. Let's try to build a RAG application on top of a sample PDF. For the sake of convenience, I have already downloaded the PDF. This is the research paper from Attention is All You Needed. Basically, this research paper is all about how this GPT network and transformer networks are way more powerful than the ordinary traditional networks. So let's try to build a RAG on top of it. First of all, we are going to need a data ingestion pipeline through which we are going to read this PDF and convert it into chunks. So we are going to use LangChain for this. Let me create a data ingestion pipeline for this. So let's call this file data ingestion. This is our data ingestion code. So let me just expand it for you and let me import the necessary libraries which I am going to use it. So from langchain.community underscore community, here is community.document loaders. This will help me to load the PDF document. We are going to use PyPDF loader. Then from recursive text splitter, we are going to use this text splitter to split the chunks of the PDF. So for this, we are going to use from LangChain text splitters. Text splitters, import recursive text splitter, There we go. Perfect. Now using these two libraries, let's read the PDF. So let me create a function def load PDF. It's inside this PDF. I'm going to supply the path of the PDF, and using this path I'm going to read the PDFs. Let's create a loader. So loader will be equal to PyPDF loader. This is how we are going to read the PDF. So on this we are going to supply the path from wherever we want to read the PDF. This path will be that path, and using this loader, let's create a documents. Inside this docs we will supply loader.load. This will load the PDF content inside this docs variable, and after we have loaded everything inside this docs, let's try to create a recursive splitter using our recursive character splitter. So this is how we are going to do it. Let's name it text splitter. So inside text splitter, let's create a text splitter, recursive text splitter. Where are you? There you go. Recursive text splitter. With chunk size, this is where you define the chunk size, how much chunk size you want. So for the sake of convenience, let's suppose I want to supply a chunk size of 500 and a chunk overlap. Chunk overlap is nothing but the amount of overlap between the two separate chunks. So chunks overlap basically 50. Basically it will take 50 words from the top chunk and bottom chunk to manage the context. This is our text splitter. Now let's create a variable text. Inside this text we will split it and we will supply to docs inside it. So text splitter dot split documents. This should be text splitter dot split documents, and inside this we will supply to docs. Perfect. And let's return it. Return text ETURN. Perfect. So what this function does, we will supply the path of the PDF we want to read. After reading the path of the PDF, it will create the docs variable inside which the each and every content from the PDF will be loaded. After that, we are going to create a recursive text splitter which will divide the document or the PDF into chunk size of 500 with overlap of 50 words. After this, we are just trying to return the same text. Now let me just call this function just to check what it is loading. So let's create a variable result. Inside this result, we will load whatever is returned by the load PDF. So inside this path, we are going to supply the path of this PDF here, which is a Tencent.pdf. So path is, so this is inside data folder. At Tencent.pdf is the name of my PDF. And let's print this result. Perfect. It should be RES. Awesome. Let me just run it through. Perfect. So right now you see it is printing everything inside this RES. So in an ideal scenario, if you want to just know what is inside the first chunk, you can see RES 0. So it will print only the first chunk. Let me just run it. So this is the content of, let me just expand it for you. This is the content inside first chunk. And if I want to print the second chunk, sorry, second chunk would be 1. The index is from 0, of course. So let me just run it. So this is the content of first chunk. We want, sorry, second chunk. And this is how you can access any chunk inside this PDF. So this is how you can load the PDF and use text splitter to create chunks out of it. Now let's try to create embedding out of this PDF. So let me create a separate file for you, which is here. So let me just delete it. Delete this one and this one. We are going to call this function from a separate file. Let me create a new Python file here, which will create the embeddings, embedded embeddings. Let's name it embedding test. So inside this, we are going to create embeddings out of this. So now let's try to create embeddings of this PDF. So just to repeat, this PDF which we are going to use, attention.pdf, we have already created a chunks out of this PDF, and now we are trying to create embeddings out of this PDF. Now to create embeddings, we are going to use Ollama embeddings here. So let me first import that library or the function from this data ingestion file. So from data ingestion, import PDF, load PDF, so that we can call it from this function. And we are going to use LangChain embeddings. So LangChain from LangChain community.embeddings, import Ollama embeddings. We are going to use Ollama embeddings here just to make everything open source. Whatever we are using here is all from open source. You can use also openAI embeddings, but that will cost you some money. So just to avoid, if you want to keep everything open source, use Ollama embeddings. It's super easy. I will show you in this tutorial. It's super easy actually. From LangChain community.vector store. Now to store the embeddings, we are going to use a vector store, which is face import. This is from Facebook. It's really reliable in terms of vector store DB. Let me create a function def create embeddings. Inside this function create embeddings, I am going to load PDF first. So docs is equal to load PDF. Inside load PDF, we are going to call the path, so which is data.attention path. This is nothing but the same PDF. So basically whatever the function returns, we are saving it in docs here. And using this docs, now we are going to create embeddings. Now let's define which embedding technique we are going to use. So let me try to create a variable which is embeddings, which will store the embedding techniques. So we have embedding is equal to Ollama embeddings. Ollama embeddings, which the model which I am going to use just for the sake of convenience, the model which we are going to use here will be llama 2 billion parameters. It's the smallest model right now available in my system. You can also use here Ollama here, or you can use Minstrel, but llama 2b is the most smallest model which is right now available in my system using Ollama. You can also use a paid API here, like from openAI API basically, but that will cost you some money for every call you make. So just for the sake of convenience, making everything using open source, I am using Ollama embeddings here. So since I have defined the embedding techniques, now I am going to create a vector store. It should be vector store. So inside this variable vector store, I am going to store the vectors, whatever I'm creating out of this embedding. So FIS from documents, inside this documents, I'm going to supply the docs which on which we are creating the embeddings, and after this we are going to supply the embedding technique. This is embeddings, it should be docs, doc not docs. So whatever the vector being created from this, it will be stored inside vector store. And if we want to store this vector locally, this is how we are going to do it. So it should be vector store dot save local, and we will specify the path here. Let me specify the path as vector db slash index. This will store the created embeddings in this path inside this folder itself. So let me just run it and show you. Let me create the embeddings. So ideally what is happening here, I am trying to read the PDF using the load PDF function which I have defined here. So after this, once I read the PDF and I return the splitted text, using this text I am going to create embeddings in this line, and which embedding technique I'm going to use is specified here. That's perfect. Now let me just call this. The moment we run this method create embeddings, it will create the embeddings and save it in our local folder. So this is the folder it has created, vector db. So inside vector db we can see the index file, which is nothing but the converted vector db of the supplied PDF in here, and the embeddings which we have used here is llama2b. Again, just to repeat myself, the embeddings which we want to use, we can specify it here. Right now I'm using llama2b. If you want to use, you can use Ollama and other open source LLMs as well. Also you can use openAI APIs if you have an account on that. Now since we have already created a vector db of the PDF, now let's create a retriever on top of this vector db, and we will create a prompt through which we will be accessing or querying through this db. So let me create a new file. Let's name it as my retriever. So inside this file, what we are going to do, we are going to write a code which will retrieve or query from the created vector db. We can also query from the cache memory where we will be creating vector data itself, but it's always better to save the vector db and do a query from there. It saves a lot of time in real-time computing. So let me first import all the necessary libraries here. First of all, we are going to need chat prompt template from LangChain. So this are the two libraries which we are going to use. We are going to use chat prompt template and document chaining, which is here. Apart from this, we will also be needing the chaining. So this is here we go. We are going to use create retrieval chaining, and we are going to use Ollama embeddings. There you go, llama embeddings. And FISS, of course I have explained you, FISS is the vector db which we will be using throughout this tutorial. Along with this, for UI I am going to just streamlight. So let me just import everything here. So this is all the libraries which we are going to need in this retriever. Now let me create a function which will load the saved vector db. So let's create a function def get db. This function will do nothing, but it will retrieve or give me the saved vector db here. So this is the saved db we are trying to retrieve. Now we are going to first specify which embedding technique which we will be using. So embeddings will be equal to the embedding technique which we have used is Ollama embeddings, and the model which we have used is llama2b. So that's the same model we will specify here. Model is equal to llama 2 billion parameters. Perfect. This is the embeddings which we have used, and with this embedding we will try to save our retrieve our saved vector db. So db is equal to face dot load local. This there are you. Let's if dot load local. There you go. And inside this, we will be supplying the path. So path is nothing but vector db and index. Perfect. So this is our path, and the embedding technique is embeddings, which we have specified here. So this is the embedding techniques which we have used earlier to save this db. Same embedding technique we will be using to retrieve it. And apart along with embeddings, we will also allow this. There is a flag allow. So basically, you need to enable this flag when you are using the vector db from your local folder. It's a strange thing that it requires in this library. Otherwise, if you are using directly from cache, you don't need to specify it. So this is your db, the saved db. This is where you have retrieved it. Let me return it. Perfect. So whenever I will call this function, it will get me the saved db. Now let me create a prompt for my function. So there you go. Let me just give a comment. Creating prompt. Perfect. Oh, that's a spelling mistake. Perfect. So the my prompt will be here. Let me create a variable. Prompt is equal to. We'll be using chat prompt template from LangChain itself. So chat prompt template dot from template, and we will be using this. Inside this, we will be specifying. Inside this, we will specify what is the context. So answer the following question based on the context. And what is the context we are supplying? Context is nothing but here. Let me give this a scroll. So this is the context which we will be supplying it. Basically, this is the saved template from the LangChain itself. I have used it most of the times, and it is most reliable. At least for basic retrievals, it is most reliable template. So here you supply the context. Context is nothing but the vector db data. So inside this context, now we will be closing this context. Perfect. Now if you want this to be more precise or more accurate, what you can supply, answer the following question based on the below context. What you can do, you can add here you are a research scientist, answer the following question based on the below context. Perfect. Depending on the accuracy, how you want this LLM to behave, you can add or remove as many background stories as you want. This is similar like giving instruction to an agent. You can tell your agent, now you can behave like a research assistant, or you can behave like a scientist, or you can behave like a college student and answer the questions based on the following context. This is what we call as prompt engineering. Although there is a, this is just a tip of the iceberg of the prompt engineering, but from an overall perspective, this is what we actually do in prompt engineering in LLMs. Just for the convenience and simplicity, we will just keep it really simple. Answer the following question based on the below context, and this is the context. Perfect. Now let me try to create a model here, LLM model. So LLM is equal to, here we will supply which LLM model we are going to use. So I am going to use Ollama. Inside Ollama, I am going to use same model which we have used throughout, Gemma. I'm using Gemma always because this is the smallest model which fits into my system. I can also use Ollama and other models, but they take a lot of memory, a lot. That's why I always prefer Gemma to be, at least for simplicity and for tutorial purposes. Just in case if you want to use Ollama, you can just change the name here. That's it. That's the only change you need to do. If you want to use openAI, you need to specify, instead of Ollama, you need to specify the openAI API here. It's that simple. Just have to change the LLM. Now once we have decided what LLM we are going to use, let's create doc chain. So inside doc chain is nothing but the document chain which we have supplied here. Create a stuff document chain. There you go. Inside this document chain we will be supplying, this is the LLM model you have to use, and this is the prompt which you have to use. You see, the LLM is nothing but the same LLM which we have created here, and prompt is this prompt which we have created. This will be used to our create document chaining. Now let's get our saved DB. So DB is equal to, we will call this function here, get DB. So this will return the saved vector store from my local system. And once we have this saved DB, we will use it as a retriever. So let me create a variable retriever, DB as retriever. See, DB as a retriever. Perfect. This DB now can be queried. Retriever basically allows you to query through this vector DB. And then we will create a chaining. Retriever chaining. Retriever chaining is nothing but creating a retriever chain. It's really simple. Create retriever chain. Inside this chain, we will supply what is the retriever we are going to use. So this is the retriever which we have created. And we will have to use this retriever using the prompt. Perfect. See, this is the prompt which we will be using. That's it. It's that easy. Now we have retriever chaining also created. Next step is just to create an UI through which we will be taking the questions and we will be writing answers there. For the sake of simplicity, let's use Streamlight here. Streamlight is really easy to use. I will show you. Let me just comment it for you. Streamlight code. Perfect. So here we will be using st.title. This will tell what will be the title of the page. So I would say basic model testing. Perfect. And what will be the input text? So input input text should be, what should be the input text? Streamlight st dot. There you go, input text. So inside whatever you will write it inside the input text, this is the variable which will be capturing it. So inside input text, just write it, ask a question. Perfect. So our input text is here. Now where we will be writing our output text. Now before we write our output text, output means the answer basically, let's first create a chaining. Basically, if we have inputted something, that means we have written something inside the input text box, we will be using result to hold the results from chaining. So we will be using retriever. So retriever chain dot invoke. On what we want to invoke? The input. What is the input? So this is how we will specify the input. input input. Oh no, let me retrace it. Input, this is the input. So invoke on this input, and inside this input the variable input text will go here. So this, we are going to create an invoke based on this input. This is that simple. That's it. Whatever the input text we have supplied, we are going to create an invoke on that retriever chain. Perfect. And whatever the output or whatever the result is stored here, basically it will get the best result out of it, and we will be writing st dot write. Perfect. We will be writing the result inside our text box. It's that easy. Now let me run this through and show you the output. Before we run this file, there is a small change needed here. Here instead of prompt, we should be using document chain. There you go. This would ideally use document chain which we have created here. So inside document chain, we have already created our LLM and the prompt. If we use directly prompt here, it will only give the context as an output. There will be no answer. Now let's run this. Now to run this, there is a trick here. You cannot directly run this as a Python file. You have to run this as a Streamlit file. Now to run this as a Streamlit file, this is how you run it. So Streamlit run, and this is the path of my file, myretriever.py. This is how you run it. Basically, this is the whole path where my retriever is located. Now let me just run it through. So this is the URL where it has loaded. Let me drag it here. Perfect. I will have to give it a little bit of, there you go. This is the basic model testing. So whatever I write here, let me just type it. What are transformers? Let's see what the output is here. You see, the moment you type anything here, you will see here the box, it will show you it's running. Once the output is confirmed, this running will stop. Amazing. So it has given us, this is the context which we have supplied, and this is the answer. I have specifically not decided which answer should be here. So let me go back to my code. There you go. I have directly decided here, put all the response, whatever the response is coming from the LLM, just put all the response here. Instead of putting all the response, what I will do, I will put only the answer here. So this is how you can do it. Basically, this gives you what are all the context that has been supplied. So the answer is what are transformers, and using cosine similarity, it is retrieving anything talked about the transformers inside the research paper or the PDF, and it is supplying one, two, three context basically, and based on these context, we are trying to retrieve the answer out of it. So we are only interested in this answer part. So I will copy it and I will paste this answer here. Perfect, that's it. Let me save it. This is the magic of Streamlit. Whatever you will save it here, it will directly, this is giving me some key error. What is this? RES answer. It's answers or answer. Let me just run it again. Perfect. So this is the context. Based on the context, this is what the transformers are. This is what are the key advantages of transformer. This is the summary. That's amazing. Now what we can do next, let me just close this. Otherwise it will keep running. Let me just close this. Stopping. And now to make it more perfect, what you can do, you can add it here inside this context that basically limit your result to 100 words. Let me just limit your result to 100 words. Perfect. So basically, the more and more instruction you will give in the template or the prompt, the answer to LLM or the answer from the LLM will be more concise. So this is how you can give, it's super easy. You can just, it's in simple English, you can type this is the instruction to you and you have to behave accordingly. It's easy, super easy, isn't it? So this is how you can create a rag on top of a PDF. It's super easy. So this is all about how you can create a sample rag application. I hope you have learned something in this tutorial. Don't forget to like and subscribe, and all the code used in this tutorial has been linked in the comment section. Don't forget to copy it from GitHub if you need it. See you in next video.